All right, so first we're going to kind of wrap up what we've talked about with derivative, and then we're going to start talking a little bit about what the second derivative tells us about the original function f of x. So first of all, derivative f of x, remember that's the instantaneous rate of change. Instantaneous rate of change of the function f. Tells us how f is changing at any particular moment. Right? That's also the slope of the tangent line. Of f. Right? So we can use that to figure out the slope of the tangent line at any point on the function f. And we recently talked about the fact that if the derivative of f is positive, then f is increasing. And if the derivative of f is negative, then the original f is decreasing. Right, so derivative of f tells us if f is increasing or decreasing. Right, it tells us that slope, the instantaneous rate of change. Now, second derivative, obviously, is the derivative of the first derivative. So it tells us a little bit about that, as well as some stuff about the original function f. So first of all, second derivative of f of x is the instantaneous rate of change of the derivative of f. So instantaneous rate of change of the derivative of f. So it's telling us the rate of change of the rate of change. If that makes any sense. Right? So it's telling us how that derivative is changing. So for this, it tells us if the derivative of f is increasing or decreasing. And in effect, if we know if the derivative of f is increasing or decreasing, what that tells us is the concavity of f. Right, so the second derivative of f tells us the concavity of the original function f. So it tells us if that is concave up or concave down, if it's opening up or opening down. And that's what we're going to take a look at down here. So if the second derivative is greater than 0, so if it's positive, if the second derivative is positive, that means the first derivative is increasing. Right, just like we talked about the past couple of days, if the first derivative is positive, that means f, the original function, the thing that we took the derivative of, is increasing. And if the derivative of f is increasing, then f is concave up. Alright, so concave up just means kind of like opening up. When you think about talking about parabolas years ago, we talk about is it concave up or concave down? Is it opening up or opening down? So we use a parabola as kind of a simple example. This would be concave up, right? It's opening up. Let's look at how the derivative is increasing. If we look over here, let's say at this point, and we look at our tangent line, it's pretty close to being vertical. Of course, my drawing is not the greatest, but it's pretty steep, but it's negative, right? It's going down to the right. As we move further to the right on the graph, our tangent line is getting less steep. So actually, it's like increasing, because let's say this first one was negative 10. This next one maybe negative 7. So it's increasing. So the further we go to the left, the slope is increasing until we get a slope of 0. Right? So it was negative, 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 then it's 0, and then it starts to become positive and still increasing. So as that slope increases, we get this rounded, kind of concave up shape. All right, so the big thing to take away from this, though, and that we'll be talking about for the rest of the chapter, is if the second derivative is positive, f is concave up. All right, so if the second derivative is positive, f is concave up. Then, if the second derivative is negative, first derivative is decreasing. And the original function is concave down. So we can look at an example here. Again, just use kind of a parabola-looking shape. And if we look at that, we start on the left, we have a slope that's positive. As we move further to the right, that slope is getting less and less steep until it hits 0. And then it becomes negative on the right side. So the slope is decreasing as we go, and that decreasing slope forms this concave down shape. So again, big thing to take away from this, if the second derivative is negative, f is concave down.